at this point I will continue with my answer. Alright, so we have x greater than 30. Remember, notice that there's no equal sign with a greater than sign. N of 100, p of 0.2, n is large, so we think about the normal approximation. So we check for the normal approximation. First, right, n is 100 greater than our limit of 50, so that's good. Secondly, the mean NP is 100 times the p of 0.25, and that's 25, which is greater than 5, so that's good. Alright, so the normal approximation is good. Alright, so the next thing we're going to do is to write this with limits and equal signs. Alright, so strictly greater than 30 means our lower limit is 31, and since n is 100, the maximum number of outcomes we can have is 100. Okay, so the very first thing we should do is to rewrite the binomial so that it has two limits, and so that both of the inequalities have equal signs in them. Okay, the normal approximation is good, so we say this is approximately equal to a normal distribution problem. We go down half a unit from the lower limit, we go up half a unit from the upper limit. The mean on the normal will be 25. Standard deviation, square root of n times p times 1 minus p. Alright, square root of 100 for n times p of 0.25 times the 1 minus p of 0.75. So this is square root of 100 times 0.25 times 0.75. It's 4.330. Okay, and now we can complete our normal probability statement. Okay, so there's our problem. The mean is 25. These two limits are above the mean of 25. So first thing, as before, is to draw the diagram. Right, mean 25. We have two limits, 30.5 and 100.5, which will likely be a long way away from the middle of the distribution. Alright, and the second distribution is our distribution of z values. We're looking for this area on the particular normal distribution under the standard normal. We're looking for this. Alright, so we're going to look for z values corresponding to the 30.5 and the 100.5. Okay, so let's grind through those calculations. So low limit 30.5 minus mean 20.5 divided by the standard deviation 4.330. Minus 25, which is approximately what, 4.5 divided by the standard deviation, and that's 1.27, and then 100.5 minus the mean of 25, which is 75-ish, divided by 4, which will be a large number, right? Somewhere between 15 and 20. Yeah, there we go, 17.44. But that's so far out there that the probability of getting from 0 to that point is approximately half. And then we're going to, from this whole side of the distribution, a half, we're going to subtract out 0 through 1.27. So the probability of getting a z from 1.27 to 17.44 is approximately a half minus the probability of getting from 0 to 1.27, which we'll look up in our tables. Alright, 1.27, 1.20, 1, 2, 3, 4, 5, 6, 7. Alright, 3980 is the area we're going to subtract out, and that'll be, I think, 1020, about 10%. Okay, that's the answer to that problem.